In the previous video, we have seen how merge sort works. In this video, let us implement it. So I'll write a function merge sort. This will receive an array. So as we have seen here, the base case is array of length 1. Whenever the length of the array is 1 or less than that, we will just return that array. So if array.length is less than or equal to 1, just return array. Now what we have to do is we have to find the middle of the array. For that, let us write mid is equal to math.floor of array.length divided by 2. So now we need to divide our array recursively. So let us call merge sort. So how do we find the left subarray? So we do array.slice function. So we start with the 0th index until the last index. So our last index will be mid. So here mid will not be included. So it will go from 0 to mid minus 1. So if our length of the array is 8, then 8 divided by 2 is 4. So it will go until 3. So 0, 1, 2, 3. So it will return the subarray with first 4 element. Similarly, right, which is merge sort of array.slice of mid. Here we are passing only one argument to slice because if we don't pass the last argument, it will slice until the end of the array. So in this section, we are dividing the array and we are calling merge sort again because first we slice this array into 2, then we need to slice it further. So this is the repetition step. That's why we are calling merge sort inside recursion. And again, this array will be sliced into 2 until the array length is 1. So in this last condition, this will return the array. So the left array at the end of this recursion will be 8 and the right array will be 4. So we have reached this step. Now we have all the arrays sliced into size 1. Now we need to merge them. So how do we merge? We compare the first element of the left array with the first element of the right array. So I will initialize an array as a return array, which is sorted array. So what I'll be doing is in each iteration, I'll be popping one element from either left array or right array, which based on which is lesser. So I'll compare while left array dot length is not equal to 0, that is left array is not empty and right array is not empty. So what this condition does is it loops until at least one array is empty. So once one array is empty, we just need to append the other array at the end of the sorted array. So what we do is we check whether the first element in the left array is less than the first element in the right array. If so, we need to pop the first element from the left array and add it to the return array. So I'll do return array dot push of left dot pop. So as you can see here, the pop function removes the first element of the array and returns it. In the else case, what we need to do is we need to shift the right array element and add it to the return array. So now we have covered until one of the array is empty, and whenever the left array becomes empty, we need to add the right array, and when the right array is empty, we need to add the left array to the end of the return array. So I check if left array length is greater than 0, then push the remaining items in the left array into the return array. Otherwise, we push the right array. Finally, we need to return the return array. So that is how merge sort can be implemented. So let us test this. I'll use the same array from the example. Let me print the response from the merge sort. As you can see, the array is sorted. So as we always do, let us log and trace the program. So I'll print the array with the one element here. As you can see, 8431672 is printed. Now I'll also print the return array here. I'll just comment this out. Now we can see 4 and 8 are combined, 1 and 3 are combined. Finally, 1, 3, 4, 8 are combined. Similarly, in the right side, 6 and 7 are combined, 2 and 5 are combined, and we have the array 2, 5, 6, 7. And merging both the arrays, we have the sorted array here. So coming to complexity, since we are dividing the array by 2 at every step, we can have log n. Also at each step, we are iterating through the items in the array. So we have n there. So the complexity is big O of n log n. So that's how we can implement merge sort. In the next video, we will see some other algorithms. Hope you're liking this series. If you are, please consider subscribing to the channel. It really motivates me to publish more content like this. See you in the next one.